Okay, so now that we've learned how we can take data and form ordered pairs and graph those ordered pairs in a scatter plot, let's now start looking for a pattern, looking for a trend, and beginning to mathematically uh, define that trend. So to do that, we're going to look at this definition of a line of regression. So what is regression? Regression is a process that uses calculus to get the equation of a line such that the line splits the scatter plot evenly and has the same slope trend as the scatter plot. So an analysis tool you create from the data with a linear trend. So down below, I've got some examples of what's considered a good fit and a bad fit. First, let's look at a couple of good fits. So you can see here on this good fit on the left, I've got a scatter plot that's represented by those dark points there. And the line of regression is the line that is a line of best fit that appears to split the data evenly and also have the same slope trend as the data points. And what you can see is that as x increases, so as x gets bigger, y increases, y gets bigger. So y gets bigger. Um, and so this type of slope, where you have a change in x values, which is positive, it's going in a positive direction, and a change in y values that is also positive, that's going to produce a positive slope. So the slope of this line going up and to the right is a positive slope. Now, something new uh, that you additionally may not have seen um, is, we've taken values of x and we've found the mean of those values of x. But if you not only take the x values and find their mean, but if you take the y values and find the mean, then the mean of the x values and the mean of the y values make a calculated point. And that's this triangle right here in the middle. And what you'll notice is that this line of regression goes through that calculated point. And it turns out that any line of regression that you draw or that gets graphed through a scatter plot is going to go through this calculated point. All right, let's look at the example here on the right. So this example on the right, again, we have a scatter plot. We have a line of regression, which is a line of best fit through the scatter plot. But now what's happening is that as we go from one point to another point on the line of regression, so if we were to start here, we would see that as x gets larger, the y value gets smaller. Okay, so as x increases, y decreases. Y goes in a negative direction. And so the change in the y values over the change over the x values, the change in the y values were negative because it was going in a negative direction. And the change in the x values is positive because it's going in a positive direction. Negative over positive means we're going to end up with a negative slope. So a negative slope is the slope of a line that's going down and to the right. So down and to the right. versus over here, it was up and to the right. And just like the other good fit, if you calculate the mean of the x's and the mean of the y's, that gives you this calculated value, which creates an ordered pair of x bar, y bar, the average of the x's and the average of the y's, to give you this triangle point. And as you can see, the line of regression goes straight through that point. So these are examples of good fits. And I think down below, I kind of gave some bullet points, of these, why these are considered good fits. Is that the line of regression splits the data evenly. The line of regression has the same slope trend as the scatter plot points. So the slope of the data is equal to the slope of the line of regression. Okay, so you can kind of see that. Yeah, let's just leave it at that. Now let's compare what we consider to be a good fit to some examples of bad fits. So, here, this first example of a bad fit, you can see we've got a scatter plot, which the scatter plot points appear to be going up and to the right. But where's our line of regression? Well, the line of regression is going down and to the right. So, you might say, well, it's good because that line of regression is splitting the data evenly, right? We've got essentially, the same number of points on one side as we do on the other side. Okay, that's good. But what's bad is that the line of regression does not have the same slope trend as our data. So the data is going up and to the right, but the line of regression that's drawn is going down and to the right. So the line of regression doesn't match the data at all. So this is considered a bad fit, because the two slopes, aren't the same. Now, if we look at another example of a bad fit, so here you can see the slope of the scatter plot, the slope of the data appears to be going up and to the right. Well, the line of regression is also going up and to the right, but it just doesn't quite match the slope of the data. It's closer, but it's not close enough. All right. Now, this third example of a bad fit, is here we have the slope of our data. And you'll notice that the slope of the line of regression appears to be the same, right? The slopes are the same. That's good. But what's bad is that this line of regression isn't even going through our data. It's not splitting the data evenly. And, this line of regression will always go through this calculated point of x bar, y bar. And this line of regression is not doing that. I mean, you'll notice, at least in the previous two bad fits, the line of regression did go through this calculated point, x bar, y bar. This one on the far left went through this calculated point, x bar, y bar. So that was at least a redeeming feature. Okay, still considered a bad fit. So these are some examples of what we would consider to be a bad fit and what would be considered a good fit. This is what you're aiming for. It's something that looks like that. Okay. Okay. So remember that the line of regression is always going to pass through this calculated point. Okay, I'm saying that this is a calculated point because you're going to have to calculate it yourself. But again, your calculator will help you with that. So let's look at learning to sketch a scatter plot as well as a line of regression. So that's what we're going to do here in this first example. So looking at this first example, we have our list of X values and Y values. And okay, so first off, I'm going to do a couple of things. First, I'm going to make kind of like an X and a Y axis here. And off to the side, I'm going to make an XY table just because it helps me see ordered pairs a little bit better because I read ordered pairs from left to right. So, our values of X, are 1, 2, 3, 4, and 5 in this data set. And then our values of Y are 2, 3, 2, 3, and 4. Okay, fix that. Okay, so whenever you're going to sketch something by hand, what you want to look for, like in the x-axis, is what are my minimum and maximum values. So the minimum value I have is a 1, and the maximum value I have is a 5. So I think if I started with a 0 and ended with a 5 on the x-axis, I would be good. So I'm going to put 0, 1, 2, 3, 4, 5. And it's not going to be perfect because I'm sketching this by hand, but I'm going to do the best I can to make um, these tick marks as evenly spaced as possible. Okay. Now I'm going to look for the minimum and maximum in my y values. So I have a minimum of 2 and a maximum of 4. Now the other consideration I'm going to do is if I can maybe use the same scale on my y-axis that I had here on my x-axis, that might be a little better. So I'm going to do that. I'm going to go from 1 to 5 on my y-axis as well. So I'm going to go 1, 2, 3, 4, and 5. Like that. Okay, so now I can just go ahead and plot my points. So I've got the point 1, 2. So 1 on the x, 2 on the y. I've got a point 2, 3. So 2 on the x, 3 on the y. I've got the point 3, 2. So 3 on the x, 2 on the y. I've got the point 4, 3. 4 on the x, 3 on the y. And I've got the point 5, 4. So 5 on the x, 4 on the y. All right, not too shabby. Okay, so before I can sketch my line of regression, it's going to help me to get this calculated point of x bar, y bar, because the line of regression has to go through it, and that'll end up helping me when I sketch it by hand. Okay, so how do we get that? Texas Instruments calculator. You want to put your x values and your y values in list 1 and list 2. And then we'll hit the Stat button, and we'll go to the Calc menu. We'll do 2 variable stats. And with 2 variable stats, you put list 1 for your list of x values, and you put list 2 down for your list of y values, and hit calculate. And you can see it gives you x bar, which is 3, and y bar, which is 2.8. So x bar, y bar is going to be 3, 2.8. So let's do that. So x bar, y bar is equal to 3, 2.8. So we're just going to do that as best we can because we're doing it by hand. So we're going to go 3 on the x and 2.8 on the y, which is just under 3. And I'm going to use a different symbol here. In fact, instead of coloring it in, I'll make it open to maybe make this stand out. So I'm using a triangle, okay, to make this a separate point. All right, now let's sketch the line of regression. So now I'm just going to draw a line, and I'm going to try and split the data evenly and make sure that I go through X bar, Y bar. So I'm going to draw something that looks like that. And this is my line of regression. Okay, it's not going to be perfect, but at least you can sketch it by hand. All right, so give that a try and let me know if you have any questions.